Welcome back to Bitcoin and Beyond. Today we have Chase from Molecule discussing a next-gen VM on Bitcoin, talking about the Solana VM and how it all works under the hood. Chase, thank you for coming on and welcome.
Yeah, thanks for having me. I can dive a little bit deeper into what I'm working on and why I'm so excited about next-gen VM on Bitcoin. I can kick things off here. So what we're building here at Molecule is really a ecosystem of SVM, blockchains, and rollups. And our main product is a what we call the fastest programmable layer on Bitcoin. The problem that we're solving here is Bitcoin has been slow, expensive, and it's not Turing complete, meaning that you can't build native dApps using smart contracts using Bitcoin script. So there are two versions of solutions that are tackling this problem. One is building a sidechain on Bitcoin, and the other one is a rollup or a L2 on Bitcoin. So for sidechain side, what that means is it usually settles on another economic layer, or it has its own consensus mechanisms. Typically, it doesn't have unilateral exit of assets. The advantage of building sidechains is it's faster go-to-market, but on the other hand, it does not inherit Bitcoin security. For L2s, it settles on Bitcoin with unilateral exit of assets, and therefore inherits Bitcoin security. It is slower to go to market because there are some R&D involved that we as an industry are still progressing towards, which I can dive a little bit deeper later on as well. So the current most used execution layer on Bitcoin L2s or Bitcoin sidechains is the EVM. It is also the most adopted execution environment in the space right now. On L1 side, you have the OG Ethereum and also other EVM chains like Avalanche. You have L2s like Arbitrum and Optimism. But what we are really excited about at Molecule is the next-gen VMs. And these VMs improve on the single-threaded EVM to enable higher throughput and lower cost. Our solution, therefore, is to bring the most performant VM, that is the SVM, to Bitcoin. And SVM provides the highest throughput with a super battle-tested execution environment and already has a vibrant developer network. So here are some stats. You can reach 1,000 true TPS. The cost per transaction is a fraction of a penny. That's more than 3,000 active developers already on Solana. And how we decide on the VM is twofold. One is we as a team has been in the Solana ecosystem for more than 2 years and have seen firsthand how Solana Foundation, together with us, activating at different hacker houses, build up a very strong community of developers. And two is really on the technical side, which is looking at speed, cost, and usability. I think speed and cost I talked a little bit about in past few slides. And usability is really about the infrastructure that's built around that ecosystem or that VM, such as EVM, SVM, and MoveVM. And that brings us to adoption, which is really the most important part. How many developers are building already? What kind of apps are being built? What kind of users? What kind of community are you attracting? That's really important as well. And here's a side-by-side comparison of the different VMs. SVM, as part of the next-gen VMs, is the most mature. It's already in development for about 5 years. And the language itself is also very unique compared to the others in the sense that the other languages are essentially Web3 specific languages, but on Solana or SVM, it is Rust. And there are already more than 3 million Rust developers globally. And in terms of TPS, it is also the most battle tested and highest one right now at about 1,000 true TPS. That's not counting any voting TPS that Solana has as well. So how we come to, I guess the conclusion that we have is really SVM is the most battle tested execution environment and therefore the most suited to solve the programmability problem on Bitcoin. And the next question that we have is, the debate between monolithic and modular vision. I think Solana has always been about the monolithic vision, and it makes sense for an L1 because you can have the execution, DA, and settlement on one chain with high throughput. But that is simply not possible on Bitcoin because of the restrictions of layer one, where you don't have native smart contracts. And therefore, we need to take a modular approach. And that is possible now with different technology or module stacks that we can leverage as well. So how we think about it.
Chase, quick question on that note. And I love the idea of Bitcoin going modular. And so I just want to, we've had some other people kind of like high level talk about the restrictions of Bitcoin at the layer one level. This might be a silly question, but why don't we just change the parameters to allow people to put more data into Bitcoin blocks and kind of provide some more processing power?
Yeah, I think that is to do with the security of the network. So because Bitcoin is I guess, super mature, and there's more than 1 trillion of liquidity that's at stake, it is difficult to make drastic changes to the opcodes on Bitcoin. But that being said, we are in the progress of having some breakthroughs in terms of more opcodes that can simplify a lot of the complicated tech that we are exploring on Bitcoin. So the one that's most exciting is opcat, which essentially enables complex transactions to be written in a much simpler and therefore occupies less space in the shared UTXO of Bitcoin. And I think that, I guess it might be a controversial take, but I do think it's going to come in the next 6 to 12 months. And the reason is, in the past, during the Taproot upgrade, we already have the opcode that's written into Bitcoin that is in the form of op success 126, and which means that code is already existent. And therefore, to reinstate that, you just have to do a soft fork instead of a hard fork. So that is like a much easier process because essentially you need to get the miners globally to come to a majority consensus. And as long as they upgrade the software, this change can go through. And that is, to me, is really exciting. It can unlock a lot of potential, calculation methodologies on Bitcoin itself and enable zkRollups in a much simpler fashion.
Awesome. Thank you for the explanation.
Yeah, for sure. I'll go on to the next page. So that leads us to the SVM rollup stack. And how we think about it is we strip out the execution layer of Solana and enable ZK verification of transactions through a zkVM and what we call a molecule prover here. Then you post that ZK snark to Bitcoin using a challenge reward mechanism. So there's a few progress in this area. And I think opcat, I talked about it already. BitVM is another way to do it. So that is really the final vision of how we want transactions to settle and be finalized on Bitcoin itself. And then dive a little bit deeper into the zkVM. How we go about doing it is in the Solana modules, there's a bank module where essentially we can take out the BPF and allow transactions and states to turn into a function, and we can plug it into a zkVM, for example, from RISC-0. And using the RISC-V ELF binary, we can then post the state change with a ZK receipt back to the SVM. And with this methodology, we can create a snark that can be wrapped into a snark that can then be verified on Bitcoin itself. And I think to go back to the adoption part, what we believe is the most important is still how many developers are developing in your ecosystem. So Ethereum definitely has a lead in this area with around 14,000 overall developers. So, but Solana is like a close, I guess it's like a second most vibrant ecosystem right now with more than 3,000 active developers. But just taking a step back, this is actually a small number compared to just globally how many Rust developers there are. So right now, based on estimates, there are more than 3 million Rust developers, meaning that we are only seeing 0.1% adoption. So we are really early, but I do think there's large potential here to attract more developers into the space. And the key here is really how can we make the user experience the easiest for anyone to come into the space? How can we build retail scale consumer applications?
Do you think this is an incentives problem, or do you think this is like a reputation problem where developers are a little bit apprehensive to be associated with cryptocurrency for legitimacy purposes? Why do you think there's only 0.1% of global developers that are currently in the Web3 community? Why aren't there more? What's missing?
Yeah, I think it's mostly to do with the maturity of the industry and education that goes along with it. For the longest time, we have been educating the public that crypto is not a scam. And I think we've come to a solid conclusion on that with the ETF of Bitcoin going through. And now there's development on the Ethereum ETF as well. It takes time for developers to realize that there's this space that they can try new things, try cool things, therefore I think it's like a concerted effort of the whole industry to push this forward. And we have seen it from Solana hack houses, for example. That has been a huge success, and Ethereum with ETH Denver and all these conferences bringing a lot of people. And I think the next step is really how the infrastructure, right? How can we create really usable blockchain ecosystems? And I think on Ethereum, for example, even with the scaling solutions, that's the costs are still relatively high, which means that you can't build retail scale consumer applications with tens of millions of users. So that's really where I do think the next gen VMs will play a big part, and SVM will be at the forefront of this. Yep. I just have one last slide here. So the question for us is really what next? So we are focusing on the SVM SDK now, where we can enable any SVM app chains. And the next step we are exploring is a decentralized sequencer. We're essentially creating sequencer network for Molecule and SVM rollups. And our final vision is to create a rollup network of SVM chains on any chain. So you can imagine SVM on Ethereum, SVM on BNB chain, and other chains as well. So super excited about this, and I think we're seeing a lot of interesting developments on Bitcoin itself. So yeah, excited to share more.
Sweet, man. Could you move back to the slide before the prover? Yeah, okay. So, all right, so let's talk about this. So this trust minimized bridge, could you please give us a bit more information about what the validators are, what the trust assumptions are, and kind of what that setup is?
Yeah, so essentially we are building we are working with a few teams on like a BitVM bridge. So the trust assumption there is really you can have a challenge prover mechanism on Bitcoin itself. So you can verify any asset transfers from Molecule back to Bitcoin. There's a challenge period where any verifier can come in and say that, hey, there's some issues, then they can go through this challenge mechanism. So that's how we think about a BitVM bridge. And another solution is really a ZK bridge that can be enabled by Opcat. So that is also in the works, and I think that will depend on how fast we push forward the industry standard. I think for a lot of other Bitcoin L2 solutions, they are choosing to go with a multi-sig bridge at first. But for us, we are thinking of building for the long term. So we want mainnet and the trust minimized bridge to go out at a similar time period.
And so does that mean that you guys won't go live until BitVM is stable?
So there are ways to simplify the BitVM bridge. For example, I think BitVM is a general purpose computation mechanism through like off-chain computation method combined with on-chain challenge prover. So there's ways to simplify that for a rollup specific bridge with less challenge mechanisms, for example. So on BitVM, there's like 6 different types of challenge mechanisms. I think there's like 50 plus opcodes. You really need less than 10 of those opcodes and one challenge mechanism, for example, for a rollup specific implementation. So we think we can push that forward faster than the general purpose BitVM implementations.
Got it. And does it require a soft fork to Bitcoin to implement those opcodes?
No, you don't have to do a soft fork for that. But for the second option, where you essentially the ZK bridge, we need a soft fork for opcat to come through.
Got it. Okay, and that is opcat is currently in bit 420, right?
Opcat, yeah. So it's currently I guess hidden with the Taproot upgrade, and then I think we can. There's a good chance that we can push forward as industry. I think there's a couple of guys like the Quantum Cat, Taproot Wizard guys pushing this initiative forward. So yeah, excited for that as well.
Cool. Okay, so in this stack, when you guys post blocks to a data availability layer, that would be like a data availability layer like a Celestia or Veil or EigenDA or something?
Yeah. So there's a few options here. There's Celestia, which has DAS and light nodes out of the box. This Eigen that's more Ethereum aligned, but I think from my understanding the cost is slightly higher. There's some newer DA solutions that has even lower costs that's coming out, and I think what's exciting also there's a few Bitcoin specific DA solutions. So I think zkRollup is one. There's Nubit as well. So I think we have a good selection of data availability layers. Some are native to Bitcoin, which is really exciting as well.
Okay, so then when this is passed from a data availability layer to this economically incentivized verifiers, is this an SVM or is this a molecule ran verifier network or like what does that mean?
Yeah, essentially any Bitcoin nodes, full nodes, they can take part in and become part of this verifier network and do and I guess verify. I guess they can challenge any transactions or blocks from Molecule. So that's really what I mean by verifier network here.
Cool. If you wouldn't mind moving to the prover graphic as well. Okay, so let's talk about this more in depth. What is the I guess let's just start with the very, very broad. Like why do you need to interact with zkVMs to reach consensus and kind of finality with Molecule?
Yeah, so the zkVM part is really producing the proofs. So instead of writing all the zk circuits ourselves, there are general purpose zkVMs that's specialized for that. So we intend to leverage the progress that they've made on the ZK circuit part. And I think, and there needs to be some changes for the SVM as well to do that. So we have essentially modified the bank module from Solana in order to interact with the zkVM.
Okay. So when you've modified this, okay, so that makes sense, right? We get the proofs, and you're able to modify this bank module to interact with the zkVM, like risk zero, succinct, etc. Now, as far as the modifications go for the bank module, do you feel that the modifications that you've made open up any vulnerabilities compared to like the battle-tested nature of SVM itself? So much so that the reason that you've chosen to use SVM is because you believe it's, if not the best battle-tested execution environment. But then by changing the bank module, don't you introduce another level of security problems or trust assumptions where we have to assume that what you guys have done to the SVM doesn't have unknown knock-on effects, which you guys may not be aware of?
Yeah, I think part of it is we'll still go through a extensive audit process. So I think that is to make sure that all the code is well written and doesn't have any security implications. And the other part is, I think what we've done is essentially writing a part of SVM to relay information that is the transaction states to zkVM. So it's not really changing, how the execution is run within SVM. And on top of that, it's the final transactions are still proven using the zkVM to create like the fraud proof and verify it on Bitcoin itself. So I think security-wise, it's probably one of the most, highest security frameworks that we can implement.
Got it. Okay. So then you're kind of referring to Molecule as like a ZK rollup on Bitcoin, but you're planning to use a data availability layer, so then it's more like a Validium. I guess, like, how much do you think that like the Bitcoin community being so, even just potentially opposed to Bitcoin L2s or very opposed to like changes in kind of like the core tech and keeping that level of security, like how much do you think that the Bitcoin community cares about the difference between like whether you're using a data availability layer or you're using Bitcoin, or kind of like what trust assumptions that you have? Like, do you think that there's a strong demand kind of for one way or the other, and has that kind of influenced your decisions?
Yeah, I think the Bitcoin community definitely demand programmability for Bitcoin, and SVM is the best solution to that in terms of throughput and cost. And in terms of Bitcoiners being diehard Bitcoin fans and doesn't want L2s, I think that's really changing rapidly. And I think it started out from Taproot upgrade to ordinals, and recently runes. So people have been seeing a lot of activity on Bitcoin. And how do you move on to the next step when you can create applications directly on Bitcoin? That is only possible by having an L2. So on Solana, I guess Solana inspired or SVM chains, a lot of consumer, scalable consumer apps can be built. So you can imagine on the payments side, you can have close to instant finality on, and I think one example is Stripe has been integrating and they show the demo of how crypto transactions work, and they actually integrated Ethereum and Polygon as well. But during that demo, they showed Solana only, just because of how fast and how cheap it is. So I do think that SVM is the best solution to the programmability problem on Bitcoin. It definitely takes time, but there are, I think, a general consensus that you need you need to have like L2 for programmability on Bitcoin. In terms of security assumptions, there's actually a few groups that are spearheading definitions for L2s, and I think the most important part is really the settlement and the bridging. So as long as you tackle that, have a trust minimized bridging solution that allows unilateral exits of assets, I think that fits in the definition of an L2 or rollup on Bitcoin.
Cool. Yeah, that's all that I have at the current moment. I appreciate you answering and fielding the questions, and for coming on. Rob, do you have any other questions?
Yeah, I've got like two unrelated questions. One is pretty specific. I guess we can start with that one. Like all the way on the last slide, you mentioned a decentralized sequencer with other SVM rollups. Would this give atomic composability between, for instance, rollups on Bitcoin using SVM and Solana?
So it will give atomic composability for any rollups on using our sequencer. So that means that it won't be, I guess, essentially composable with Solana, but it's relatively easy to bridge from an SVM chain to Solana, for example. There's also a few providers who are doing solutions like that, for example, Hyperlane. So I think that is really how you can transfer assets between SVM chains and Solana itself.
Cool. And so Hyperlane would enable like interoperability between a Bitcoin SVM rollup and traditional like either Solana L1 or Solana rollups.
Yeah. I think that's something that, from our understanding, their tech can offer.
Nice. Yeah, we're fans of their tech as well. Cool. And then the second question I had, unrelated to that one, was like just it was like a higher level question, like more in general here. I'm curious why you think like Bitcoin rollups and Bitcoin sidechains, Bitcoin L2s in general are going to succeed where Lightning Network and some of the attempts at scaling Bitcoin have failed in the past. Do you think, for instance, Lightning Network was just payment channels and it just was too simple? There wasn't like enough that we could do with it, and that's why it didn't really get a lot of adoption? Or generally, like why do you think those iterations failed? Why these are in position for more success?
Yeah, I think timing is definitely a big thing. It took time for people to really get accustomed to the fact that potentially there can be dApps that's built on Bitcoin. And I think in Lightning's case, there are many issues with Lightning. For example, I think the operators have been online at all times, and there are because of that, I think adoption is low for Lightning, and I think people have started to shift camp towards the L2 side because that is where truly any application can be built. So that's something that's really exciting as well, because I think Lightning has really paved the path for Bitcoin usability, and also I guess another part is Lightning is more focused on payments. I don't think they are focused on general purpose L2. So that creates like a space that's I guess ripe for development, and together with rollups on Ethereum, that's really showing like what can be done. That sort of inspired this wave of exploring programmability and usability of Bitcoin.
Awesome. Chase, thanks so much for coming on and for sharing Molecule. Very excited to see this go live and for Bitcoin to scale in general. So thank you.
Yeah.
Thank you, Chase.